Okay, we're here at the bottom of page 4. We're looking at an example of the application type exercises you're going to see. So we're in 1.8, page 4b. This is our very last video for the material in chapter 1, and the exam covers all of chapter 1. And you've got a graph here. You've got a mathematical model. So the graph has the real data where they went and counted all these things and recorded the years, and so there's real data represented here. The model is the formula. Model equal to a formula equal to a math equation that approximates, the real data. As you look over here at the graph, you've got, sort of looks like there's a tendency to grow. It sort of fits a straight line. In fact, we call that in algebra and mathematics, that's the line of best fit. So you kind of look to see what's going to be the best fit, and then there's an equation, an algebraic equation that will describe that line. Now, actually, I jumped ahead of the game here. This actually curves a little bit more here. I'm going to draw that a little bit better. Shouldn't have headed up that way. So we've got more of a curve here. So the formula that they have here involves exponents. You've got kind of a curved line going. So let's read what they have. And once again, the actual problem up above it in the book is where you'll find the model and the graph that they're using. So it says use the formula, okay? The formula meaning the mathematical model to find the number of inmates in thousands in the year 2000. Does this underestimate or overestimate the actual number shown by the graph by how much? So you're going to take this formula and use the value that they give you here to come up with a value for I, and then compare it to the I in the graph. So we need to understand what they're giving us here. They're giving us a graph where here's the years, 80, 90, 95, 2000, 2004, and here's the number. And these numbers of inmates here is times 1,000. So in 1990, it says 774. What that means is that in 1990 there were 774,000 inmates. Okay, because of it's represented in thousands here. So that's one thing to watch for, how they're representing the data in terms of numbers. Now let's also take a moment to read what the model is described as. So the model, I equals negative 0.09 n squared plus 53n plus 315, describes the number of inmates I, so it comes up with the value here that kind of lands on this curved line, and again in thousands, in years after 1980. So N is a number that you plug in that represents a year. But when they ask us to find the number for the year 2000, we do not want to put 2000 into this formula because that's not what N represents. N represents how many years have passed since 1980. So between 1980 and the year 2000, that's equal to 20 years. So what we're plugging in is N equals 20. So you would go through that, you would set that up, you're trying to find what I equals number of inmates, negative 0.09 times n squared plus 53 times n plus 315, and you will put 20 in. Now, this is a little bit more intense than I would do on a calculator-free exam, but it's good practice to kind of work through it a little bit here. The numbers aren't too bad, so we'll keep going, we'll push through. 20 squared is going to give you 400, so this becomes negative 0.09 times 400, plus 53 times 20, so double the 53, it's 106, add the 0, 1060, plus you've got your 315. 4 times 9 is going to be 36, and then you add 2 zeros, 3600, then you take away the 2 decimal points, you're back at 36, and it's negative. So it's negative 36 plus 1060 plus 315. Okay. And then you can go left to right, or you can see if there's any sort of combination. I think just straight across will be the easiest way to go here. So I equals negative 36 plus 1,060. You're going to subtract and keep the positive sign because it's the bigger number. So you're going to get 1,024. Then you're going to add 315 to that. I'm going to come over here. I'm running out of room here. 1,024 plus 315 is 1,339. And that's going to represent your thousands. So remember, that's times 1,000. Or you can just look for the 1,339. Remember, this is in the year 1980, so now we're going to compare that to the graph. We're going to compare that right here. And the value in 1980 is just 330. Now let's make sure I did this right here, because that seems like a big discrepancy. Numbers after 20 times 20 is 400 to 20 times 53. This is negative. Maybe I did the multiplication wrong here. 9 times 4 is 36. Add the two zeros. 0.09. Take it away. So I've got negative 36. 1,024. 1,339. Wow, to me this looks like it's way off here. It doesn't quite take care of the data in 1980, because the data here says the real data said it should be just 330. So something makes me think that I've got this 1,000 wrong here. Oh, there it is. No, it is 106 with a 0. Well, let me look at this here. I'm gonna. How much time am I doing on the video? Some of you are probably seeing my error and going, I can help you. Stop. I'm just double checking here. Negative 0. This is when the pressure's really on, right? The camera's rolling. You're trying to figure this out here. If I pause it, I have to start the video all over again because I don't have a way to connect these videos to each other. So I'm just kind of vamping here while I'm seeing if I can find my mistake. Okay. Well, right now I think this overestimates that because I'm reading that graph at 330 for 1980. Oh, phew, now I found my mistake. My math is right. I'm sorry, 1980 is based on the formula. 2000 is what we were supposed to compare to. Oh my goodness. So 2000 has a value of 1,392. So the graph has a value of 1,392. The model or the formula gives us a value of 1,339. Here I was thinking I was doing the math wrong and I was just misreading which year on the graph. Oh dear. And that's pretty good. The model underestimates it, but when you remember that these are in thousands, this underestimates it by, what is that? That's 53,000. So it underestimates by 53,000 inmates. That seems like quite a bit of an underestimate, but depends on what they were doing the data for too. But that seems like quite a bit underestimated. But the interesting thing about this particular model is when they describe it as a curve here, eventually, if that curve continues, that true equation, if this really was able to predict the future, eventually this number would then start to drop because this curve is going to max out here and then come back down. So it'd be interesting to see current updated data to see what happened if there was another spike and really indeed this is linear. More people in prison than any other Western nation. Bar graph shows the number of inmates over the years. So it's an example, in my opinion, of real data with a mathematical equation where the math is just approximating. You can't really tell the future with this because anything could change. There's so many other things that affect why people are in prison and what kind of law enforcement and what kind of judicial system and puts them there, keeps them there. But it's an interesting exercise to see how the math relates to the real data. But again, it's not an exact science. You've got someone who is looking at these or a team of people and creating this equation that then creates a line on the graph that sort of approximates the data as best they could, a best fit. And in this case, well, they're 53,000 underestimating for 2000. What will that mean if they were trying to estimate what kind of space they would need in 2008 or 2010 or today in 2013? But it's an interesting thought how the math applies there. All right, we will see you in the next chapter as we start getting ready for the next exam.